Here's the translation of your script into English. I've kept the conversational, energetic tone of the original while making sure the scientific details are accurate and clear. Let's start with a rule, the oldest one in nature. If something is the exact same shade as your highlighter, do not touch it, do not poke it, and for the love of everything, do not lick it. Stay away. Simple, right? So simple you'd think it doesn't even need to be said. And yet, scroll through your phone for 5 minutes and you'll find a parade of people doing the exact opposite. Someone cupping it in their hands, someone else jabbing it with a finger, and one guy, I'm not kidding, trying to feed it a piece of orange, all for the views, all for those 15 minutes of virality. Because these things are tiny and pretty and look completely harmless. What's the worst that could happen? What's the worst? You could die. Why does this already sound like the intro to a news segment? I'm Lindsay Nicole, and this is another episode of Asterisk. But today, I don't just want to talk about asterisk, how toxic asterisk they are. That's too surface level. What I really want to dig into is a much trickier question. Why do some organisms basically scream, I'm lethal, with their looks? Or did they not write that message at all and you just read it into them? Don't worry, we'll peel it apart layer by layer. As always, we start with location. You need to know where something sits on the tree of life, or nothing else is going to make sense. Take a look at this evolutionary tree. See all those big groups called phyla? They show you how everything is related. Notice that, except for the last one, chordata, which is us vertebrates, every single other phylum is invertebrates. So all 3 of today's stars are invertebrates. Surprise, surprise, this series has been like that from day one. There are millions of invertebrate species, millions. That means basically everyone, including scientists, is a total noob when it comes to most of them. Our brains can only hold so many species. Here's today's lineup. The blue-ringed octopus and the blue dragon, both in mollusca, the same family as squid, slugs, and clams. And the Portuguese man-o'-war in Cnidaria, alongside jellyfish, sea anemones, and corals. Got those pinned? Good. Now let's talk about just how unreasonable they really are. Let's start with the key concept. The key to today's whole episode, aposematism. Many species have evolved the ability to produce toxins or venom as a defense against being eaten. But just having toxins isn't enough. You'd still get bitten before the predator dies. So they also evolved a physical warning signal. Basically, they shout to the whole world, S-T-A-Y-A-W-A-Y-F-R-O-M-M-E. That's aposematism. And here's the thing, it's not camouflage, it's the exact opposite. I used to think the word conspicuous meant hidden or invisible. Don't laugh. It sounds so mysterious, right? Then I looked it up and realized, no. It means you stick out like a sore thumb. You are screaming in everyone's face. Translation: if you mess with me, I'll make you pay 10 times over. Also, aposematism doesn't automatically mean lethal. It's more like a general broadcast. I'm toxic, or I taste terrible, or even just eating me is a waste of your time. Think of a skunk. You won't die, but the experience is memorable. The black and white color scheme alone should hit your brain's emergency brake. So does this strategy actually work? Look at it through an evolutionary lens, and you'll be blown away. Aposematism has evolved independently, repeatedly, in at least 1/3 of all animal phyla. That's convergent evolution, not one lucky lineage, but natural selection coming up with the same solution over and over again across completely unrelated groups. Quick caveat, at least 1/3 is the current lower bound that we know of. There could be more, we just haven't counted them all, but the conclusion is already solid enough. When a solution gets independently invented that many times, it must be doing something right. Alright, enough theory. Let's meet the stars. First up, the one that guy was holding while trying to feed it an orange. This is one of the most venomous marine animals in the world, the blue-ringed octopus. That video went viral in 2021, filmed in Bali. But it's hardly the first time someone ignored the warning signs. There are enough examples to serve them up on a silver platter. Blue-ringed octopuses are a genus with at least 4 species, all using the same playbook. They live in coral reefs and rocky seabeds across the Pacific and Indian Oceans, and sometimes you'll find them in tide pools. Quick fun fact, the plural of octopus can be octopi octopodes or octopuses take your pick. The name comes from the bright blue rings that flash across their bodies when they feel threatened. But here's a plot twist. You'd think aposematism works like a poison dart frog. 24/7 neon lights, screaming, "Stay away" to everything, all the time. The blue-ringed octopus doesn't do that. Normally, it looks like a rock, or like the inside of a crevice. It just sits there, quiet and unassuming. Only when you really annoy it, when it feels unsafe, do those blue rings light up like a switch. How does it do that? With pigment cells called chromatophores all over its body, plus special reflective cells called iridophores. Think iridescent, that rainbow sheen. It flashes like a strobe light. So why doesn't it stay bright all the time, like a poison dart frog? It's not shy, it's doing the ecological math. Keeping those warning colors on all the time is expensive in terms of energy, and it also turns you into a highly visible target for any predator that can handle the toxins. The blue-ringed octopus chose a switchable alarm system, low-cost stealth most of the time, full neon when it matters. It's just another adaptation strategy, no better or worse than the always-on model. Now, just how toxic is it? Let's ditch the urban legends first. You'll hear things like, one blue-ringed octopus can kill 26 people. That's all allegedly territory, vague sources, hard to verify. We're not touching that. Here's the hard data. The blue-ringed octopus produces a super potent neurotoxin, tetrodotoxin, or TTX. It's not unique to them. Some salamanders, the polyclad flatworms we talked about last episode, and the most famous one, pufferfish, all produce it too. 2019 Japanese team studied the toxicity distribution in the greater blue-ringed octopus. Turns out it's not just the bite that's toxic, the whole body carries the toxin. So I bet someone in the comments is already asking, can you eat it? No. There have been multiple cases where they accidentally got mixed into fish markets, and people ended up with food poisoning. The unit they used in that study is pretty grim. It's called a mouse unit. 1 unit is the amount needed to kill a mouse within 15 minutes. Don't shoot the messenger, I'm just reporting the science. Anything above 1,000 mouse units per gram is considered highly toxic. Now guess what they found in the salivary glands? Go on. 9,276 μg. 9,276. From a normal person's safety perspective, my reaction is, oh my God, that's horrific. But from a scientific and evolutionary perspective, my reaction is also, oh my God, that is sick. The same thing, terrifying and awe-inspiring, 2 sides of the same coin. What makes it even scarier, the bite is almost painless. Many people don't even notice until symptoms start. TTX works by blocking nerve cells from transmitting electrical signals. No signals, no muscle movement. So you get muscle paralysis, respiratory failure, and then death. And so far there is no known antivenom that we know of. How do you prevent it? Don't touch, and definitely don't pick one up. Next up. This one has been covered by almost every animal YouTuber because there's just so much footage of people being reckless. If you've been in animal social media long enough, you probably already know that's not a jellyfish. That's a Portuguese man-o-war, related to jellyfish, looks like one, but completely different. Its tentacles can reach over 30 meters long. Its sting hurts like hell, and in rare cases, it can be fatal. Let's break it down. The Portuguese man-o-war is a siphonophore, phylum Cnidaria. Same family as jellyfish, sea anemones, and corals. Corals are animals. Yes, honey, that blew my mind too when I first learned it. Although it looks like a weird jellyfish, it actually lives more like a coral, because both corals and siphonophores are asterisk colonial organisms. Asterisk. They're made up of countless tiny individuals called zooids, all attached to the same body, connected by tissue, none of them capable of surviving on their own. A bit confusing, right? Here's an analogy. Imagine leaves on a tree, but animal style. In other words, the Portuguese man-o-war is not a single organism, it's a colony. And here's the wild part. The zooids actually specialize. Some handle feeding, some handle reproduction, others handle defense and hunting. That thing floating on the ocean's surface is actually a whole team of specialized workers. So how did this colonial lifestyle evolve? I need to hit the brakes here and make this clear. What follows is speculative territory. The evolutionary path of colonial animals is still poorly understood with limited evidence. They grow through a process called budding, which is asexual reproduction, basically cloning. Other animals bud too, some sea anemones for example, but their buds just drift off and live independently. A reasonable hypothesis is that at some point, maybe multiple times, the budding process got stuck. The new individuals didn't fully separate and remained permanently connected by tissue, forming a colony. But let me be upfront, this is a plausible idea, still an open question that we know of. I won't present it as settled science. End of speculation zone. Back to hard mechanisms. How does it sting? Not TTX, it uses the shared Cnidarian weapon, nematocysts. Yes, the source of your childhood beach trauma, when you got stung and someone made you pee on your leg or begged someone else to do it. The mechanism is almost mechanical in its elegance. Each nematocyst contains a coiled thread-like structure with a trigger. When triggered, a harpoon-like tubule fires out, pierces the skin like a needle, and injects venom. For the Portuguese man-o-war, that venom is nasty, typically about 20 minutes of excruciating pain, whip-like welts on the skin, nausea, and in severe cases, chest pain and breathing difficulties. Fatalities are rare, but they happen. It floats on the surface using a gas-filled sac, the pneumatophore, with the rest of the colony, and those deadly tentacles dangling underneath, drifting with the currents, waiting for prey to stumble into them. Third, and the one I'm personally most hyped about, asterisk Glaucus atlanticus, asterisk the blue dragon, also a mollusk, also one that makes you pay if you tick it off. It's a type of nudibranch sea slug, and by the way, sea slugs are my absolute favorite marine animals. Many nudibranchs have a Marvel-level superpower. They steal their prey's weapons and use them as their own. Take the aeolid nudibranch for example. It eats sea anemones, which, like the Portuguese man-o-war, have nematocysts. But the aeolid doesn't get stung like other hapless victims. It evolved the ability to neutralize those stings and actually recycle the nematocysts, absorbing them through its digestive glands, sorting them, and storing them for its own defense. And it gets even crazier. Some nudibranchs, like the leaf slug, do the same thing with plants, effectively becoming solar-powered by stealing chloroplasts from plant cells and using them for photosynthesis on a temporary basis. Imagine if humans could do that. What a trip. And the blue dragon's prey, the Portuguese man-o-war, our second star. Every crazy feature here maps to a survival problem. The blue dragon is small and slow, about an inch long, drifting in the open ocean. No shell, no speed. How does it survive? Answer: it turns its most dangerous neighbor into its own personal arsenal. It evolved immunity to the man-o-war's deadly defense and learned to hijack those powerful weapons for itself, a mechanism called kleptocnidy. A tiny creature with almost no offensive capability, armed to the teeth through theft. And let me be clear, this isn't cleverness in a human sense. It's the solution natural selection found for a weak body trying to survive. So when you're on the beach debating whether to lick a blue dragon, you're basically playing Russian roulette. You might feel nothing, or you might taste the full wrath of its lethal prey. Now here's the elegant twist that ties it all together. Remember Aposematism from the beginning? Strictly speaking, the Portuguese man-o-war and the blue dragon are not examples of Aposematism. They're the opposite. That blue color is camouflage, a strategy called countershading, designed to blend into the blue of the open ocean, making them hard to spot from above or below. So that whole loud warning signal thing I set up at the start, that really only applies to the blue-ringed octopus. These other two are on the stealth route. And this is what makes nature so fascinating. The same surface blue can serve completely opposite functions. In one species, it's "look at me," in another, it's "you can't see me." The meaning of color depends on the evolutionary pressures behind it, not your intuition. Though I will add this personal aside, when those little blue things wash up on the beach and you're thinking about licking them, that blue should absolutely be treated as a warning color. Just my 2 cents. So what does all this have to do with us in the real world? Everything. And it's all in those videos. Blue-ringed octopuses occasionally end up in fish markets and have caused multiple food poisoning incidents. Social media is overflowing with people doing stupid things with them. And Portuguese man-o-wars can still sting you, even when they wash up on the beach looking deflated. But let me be very clear, I'm not trying to spread panic. The real risk comes from ignorance from these animals seeking you out. None of them are out to get you. The blue-ringed octopus hides in crevices. The man-o-war drifts around waiting for plankton. The blue dragon is busy stealing weapons. Their toxins and defenses are exactly that. If you don't bother them, the odds of an encounter are really low. So we circle back to that opening rule. It's as simple as it gets. If you don't recognize it, don't touch it. As a species, we really should have come to a consensus. Finally, let's draw the line between what we know, where these three sit on the tree of life. Portuguese man-o-war in Cnidaria, the mechanism of TTX blocking nerve signals, the hard number of 9,276 mu, D in the octopus's salivary glands, the mechanical firing of nematocysts, the kleptocnid defense of the blue dragon. What we don't know or can only hypothesize, the evolutionary path of colonial organisms is still an open question. There may be more blue-ringed octopus species waiting to be described, and there is no known antidote for TTX that we know of. To completed answer sheet. It's a map that's still being drawn at the edges. And those blank spots, they're the most exciting part. So drop a comment. What other highlighter-colored equals do not touch warning organisms do you know? Or do you have questions? Let me know. That's what we know so far, and new discoveries might be on their way.